Hello, my name is Hoang Nguyen. I'm an application scientist here at Micromeritics. We're the world's leading supplier of high-performance instruments to characterize particles, powders, and porous materials. Today we're going to look at the AutoChem III system for dynamic chemisorption measurements, including post-chemisorption and temperature program experiments. The AutoChem III offers the highest quality data, greatest productivity, and safest operation for the characterization of catalysts to dynamic chemisorption or temperature program experiments. The system employs a highly sensitive, robust TCD and a temperature-controlled flow path for accurate gas analysis and can also interface with a mass spectrometer for further selectivity. 6 inlet ports each for carrier, loop, and preparation pathways, totaling 18 gases can be plumbed simultaneously. This is especially useful in labs where many types of characterization are needed, reducing the time spent changing gas connections. The AutoChem III can perform temperature program experiments and post-chemisorption. The process to perform each kind of temperature program experiment is the same. They differ only in the sample chemistry and the specific gas used for preparation and analysis. Today, I'll demonstrate a TPR of copper oxide on alumina and a post-chemisorption experiment. A sample of known mass is placed in the sample tube with quartz wool support. The sample tube is mounted to the instrument with the lever-actuated quick connect. This patented mechanism is easy to use and eliminates errors associated with sample loading that may vary from operator to operator. Sample thermocouple can be adjusted as needed, up or down, either inside or outside the tube itself. Temperature program reduction of metal oxides produces water vapor as a reaction product, which must be removed from the gas stream for detection. Traditional TPR systems rely on a cold trap, which is difficult to prep and has a useful life of only a few hours. The new AutoTrap removes water vapor with a long life, regenerable sorption trap, and no cold trap or slush bath is needed. The AutoTrap can be regenerated automatically with the dedicated in situ mantle through a program experiment or scheduled by a calendar interval in the software. The AutoTrap allows users to fully automate TPR analysis with no user intervention or disruption. This is also a much safer alternative to cold slurries prepared with liquid nitrogen and isopropyl alcohol in a vacuum dewar. The sample is now ready for analysis. Let's take a look at setting up the analysis file in the software. For reference materials, such as copper oxide on alumina, pre-programmed conditions for the materials can be selected by using the reference analysis option. Then under Method, select copper oxide TPR. Methods can be customized and saved for future reuse. Visual pathways and highlighted changes make it simple to design complex sequences. Here, notice the continuous flow of vapor is blended into a carrier stream that goes to the sample and then through the TCD. During a temperature program reduction, the sample temperature will ramp at a constant rate while the detector measures the change in gas thermal conductivity leaving the sample. At the end of the analysis, the systems return to ambient temperature to ready for the next experiment. The AutoChem III has a dedicated cooling for the sample port using dry air from the compressed air source. This allows faster cooling and makes it easier for users to handle these components following analysis. The embedded AutoCool technology reduces cooling time by 30 minutes, so the system is ready for the next experiment. Now that the analysis method is defined, simply update the mass and sample information and press Start to begin the analysis. To provide absolute quantification, the system uses an automated 10-step calibration that blends gas using the patented high-accuracy blend valve to translate TCD signals to active gas flows. An automated calibration is also available for vapor flows. Here, the calibration is applied to the copper oxide reference run. Notice the TCD signals are now translated to active gas flow rates. Peak integration can be automated, or it can be user-selected. The general procedure to set up an analysis is similar across different types of dynamic chemisorption. For comparison, here is an example of a temperature-programmed desorption of calcium oxalate monohydrate decomposing to produce water, carbon monoxide, and CO2. A post-chemisorption experiment of carbon monoxide over platinum alumina catalyst can be used to measure active metal dispersion or fractional coverage. During a typical post-chemisorption experiment, this catalyst is prepared by reduction, passing hydrogen through the sample while heating. Next, the flow is switched to an inert gas, such as helium, and the temperature is lowered to the analysis temperature. Several discrete calibrated doses of carbon monoxide are pulsed to the sample until it is saturated. Detector signal peak areas increase with each successive dose until they are stabilized. Saturated peaks are the largest as all the active species makes its way to the TCD. The amount of carbon monoxide absorbed is used to determine metal dispersion and the number of active surface sites. Vapors can be also introduced as pulses to the loop. This is useful for experiments such as temperature-programmed surface reactions, where a mass spec is also used to identify reaction products driven by specific active sites. Once an analysis is complete, several built-in reports can be used to quickly process and report the results of the analysis. Users can also develop advanced reports through the creation of Python scripts. The new AutoChem III saves you hours a day, makes the most sensitive and reproducible measurements, and enhanced safety for catalyst characterization, whether developing and screening new catalysts or performing routine measurements for process control. Thank you for joining me today. If you have any questions or would like to learn more about the AutoChem III, visit us at micromeritics.com/AutoChem.